Okay, welcome back again. Session 12. We're moving on from graphs, some of you will be pleased to know. And we're moving on to this session is going to look at solving simultaneous equations. All the different types that you could be faced with, and then some practice for you at the end. Okay, so right, let's get going. Okay, solving simultaneous equations. I'm going to show you three examples because there's three different sort of types you need to be aware of, really. So EG1 is a linear type. So you're asked to solve it, which means find out what x is and find out what y is. And you could be asked to solve this, okay? Now, there are different ways of doing this, but when it's written in this form, my preferred or recommended way is to always look for the elimination method if you can. So elimination means you can subtract or minus or add the equations to eliminate one of the terms. And you can do this quite quickly actually because the y is already the same. If you minus the equations, you get a situation where you just get 2x equals 4, and then immediately you can work out that x equals 2. Okay, I can then substitute that back into any one I want. I'm going to substitute that into the second one because it's just easier to deal with. So I get 2 plus y equals 1. Y is going to equal -1. Okay, I can always check in the top equation. I get 6 minus 1 equals 5. So check in 1, and I've done that in my head, and that works. So I know that those are my answers. X is 2. Y is -1. That's the elimination method. Don't forget about that method when we look at the sort of more advanced ones coming up. Okay, EG2. This is another linear type, two linear simultaneous equations. So we've got y equals 2x plus 1 and 5x plus 3y equals 14. Okay, so we're solving this equation. You see this is written in a slightly different form. I could rearrange it and then do elimination. But in this case, because y is already equal to something, what I'm going to go for here is a substitution method. Okay, I'm going to go for a substitution. And I know that y is equal to 2x plus 1. So in the second equation, wherever I see a y, I'm going to replace it with 2x plus 1. Okay, that's legal, that's fine, isn't it? I've taken the y out of the second one and I've put in 2x plus 1 in its place. And then I can solve this as usual. 5x plus 6x plus 3, 14, 11x. X should equal 1. And then I'm going to substitute this into the easy one again. So sub into equation 1. So I get y is going to equal 2 times 1 plus 1. Y is going to equal 3. Okay. I'm going to do a quick check in the second equation for good exam technique. So I've got 5 plus 9. 5 plus 9 is 14. I know that's correct. Okay. Right, that's substitution, elimination. You can choose either method, but just my recommendation is don't forget about one. Just pick whatever's easiest depending on the question you're given. Right, EG3. Now this one is slightly different. Okay. Right, this one is this has got a quadratic in it. It's got a y squared here. So this makes it different to the other two we've just looked at. And you must, for these, use substitution. Okay? You can't eliminate these because there's just no way of eliminating a squared and a non-squared term. So I always, for these, I rearrange the linear. So in this case equation 1, to get y equals or x equals, whatever's easiest for you. And I'm going to choose x equals. There's a reason for this, because if I had y equals, I'm going to have to replace the squared term, which will get a bit nasty. I want to try and substitute the easiest thing in. So I'm gonna just get x equals something, because that will stop me having to deal with that first term. To do that, I minus 3y, and then I divide by 2. So x is going to equal 5. Now I'm going to keep it as a fraction. So keep as fraction. For A level, generally we like to keep things in fraction form. They're so much easier to deal with if we do that. I'm going to call that equation 3 because I've manipulated it from 1. And I'm going to substitute sub 3 into 2. So wherever I see an x, I'm going to put 5 minus 3y over 2 in its place. And that's the reason why I didn't want y equals, because I would have had to replace the first term and it would have been harder to solve. So 2y squared plus 5 minus 3y 2 times y, 12, okay? And I go ahead and solve this. Now, tip for this, I've got a fraction here which is a bit messy. I'm going to times every term by 2, and that's going to help me before I even do anything else. So I'm going to get 4y squared plus 5 minus 3y equals 24. Okay, I can multiply out the brackets now. It's going to be 5y minus 3y squared 4. So I've got 4y squared. So I've just got y squared. 4y squared minus 3y squared y squared plus 5y. If I bring the 24 over, now I've got it equal to 0, and I can solve this. This will usually factorise these sort of questions. Yes, that it does. I think it does. It's going to be 8 and 3. That times is to 24. That's to 5, and it's going to be positive 8 to 3. So my y values are going to be 3 or negative 8. Now, if I substitute that into x, I'm going to use my equation 3 because that's x equals. I'm just going to rewrite that under here. So I know that x equals 5 minus 3y over 2. Okay, that's just in the back of my mind. And I'm going to substitute this in. So I know that x, each one separately, x is equal to 5 minus 3, 2. So that's going to be x equals 5 minus 9 minus 4 over minus 2. And over here, x equals 5 minus times negative 8 over 2. So that's going to be 5 plus 24, which is 29 over 2. Okay, 29 over 2. And I think that's... I can now check that in my other equation. If this would be a calculator paper, probably. I could check that by substituting my values into here, just to see that it works, okay? Which it will do. Right, what I want you to do, I've got a worksheet on you. Now, there are some questions like the beginning ones, which are both linear. You can choose substitution or elimination. My advice is just to pick the one that's easiest. Don't forget about one or the other. Have both up your sleeve. But when you get to the quadratic types, you have to use substitution. Okay, so you have to. And remember, do the extend questions as well. And that is it for today. Well, that's it for session number 12, which marks the end of today as well. So hopefully you had a good day, and I'll see you again for session number 13. Thanks a lot.